Welcome to The Explainer. Okay, we're doing something a little bit different today. We are taking a really deep, systems-level look at the actual blueprint of our modern world. Whether it's the growing anxiety we're all feeling around climate change, the fragility of global supply chains, or honestly, just the rising cost of groceries, it kind of feels like a lot of the systems we rely on every day are starting to crack under pressure, right? So today, we're undertaking a deep systems thinking critique of exactly how we grow our food, manage our resources, and even structure our society. We're going to look at that blueprint and ask, are the foundations we've built actually designed to last? And as you'll see, we'll be contrasting our current industrial models with some truly fascinating ecological design alternatives that offer a much more resilient path forward. So why does our food system operate like a factory? It's a huge, vital question that we rarely actually stop to ask. For decades, and especially since the post-World War II industrial boom, the absolute dominant approach to agriculture, and really human development overall, has been driven by this deeply mechanical worldview. We came out of the mid-20th century with incredible technological power, and we just applied that exact same assembly line logic to the natural world. Think about it. We look at a living, breathing, insanely complex landscape, and we treat it like a machine. We try to engineer it to streamline the efficiency of just a single product, standardizing everything from the soil to the seeds. But what happens when you force complex natural environments to behave like rigid machines? Well, the friction is immense. When we force nature into these rigid, mechanical boxes, we basically expose ourselves to massive vulnerabilities. By demanding that kind of mechanical order, we create systems that are completely reliant on heavy external inputs. Think about the immense subsidies of synthetic chemical fertilizers and the continuous burning of fossil fuels that are required just to keep the whole operation running. It's incredibly linear. We generate massive amounts of unused toxic waste because natural biological loops are entirely severed. We enforce uniform monoculture, which basically strips away all vital biological exchanges. And honestly, worst of all, we create something called feedback blindness. This means we lose the ability to respond to subtle ecological cues. It's literally like driving a car with a dashboard, where all the warning lights are taped over. We end up ignoring degraded topsoil and polluted waterways until the crops completely fail, simply because we're way too busy trying to control nature rather than actually listening to it. Which brings us to a powerful alternative paradigm: permaculture, the conscious design of agriculturally productive ecosystems that have the diversity, stability, and resilience of natural ecosystems. Originally coined by Bill Mollison and David Holmgren back in the 1970s, you've got to understand that permaculture is not just a set of clever gardening techniques for your backyard. It's a total paradigm shift in our sense of place and purpose. It's about moving upstream from that mechanical worldview I just talked about to a deeply ecological one. Instead of fighting against the grain of natural systems, we align our designs with the evolution and inherent wisdom of those systems. We're working with nature rather than against it. To make this massive shift a reality, David Holmgren's 12 design principles offer us an ecological blueprint. Synthesized in 2002, these 12 principles essentially act as a toolkit. They are conceptual doors that open up into macro-level systems thinking. They give us a lens through which we can completely redesign our lives, guiding us on how to transition away from high-carbon, super-fragile industrial societies toward decentralized, self-reliant, and ecologically sound communities. And the true beauty of this framework, it is entirely scalable. These principles apply just as well to a tiny urban balcony garden as they do to a 1,000-acre working farm, or even a human organization that's just trying to improve its workflow. Now, the starkest difference between the mechanical worldview and the ecological worldview lies in how they view energy and waste. The mechanical model is totally reliant on dominating landscapes and forcing linear processes that inherently create pollution. In fact, permaculture simply views pollution as an unused yield, or toxic chaos. Picture massive agricultural runoff carrying synthetic fertilizers straight into our rivers, eventually creating those massive oxygen-starved dead zones in the ocean. That is textbook toxic chaos. The ecological worldview, by contrast, relies on passive, regenerative, natural services. It closely observes how every single biological element actively modifies its environment, and it seeks to seamlessly close systemic loops, so the waste of one process perfectly becomes the crucial food for the next. Let's look at how this plays out in the dirt. On one hand, you have monoculture uniformity. You plant one thing, you get one thing. But man, you are incredibly, dangerously vulnerable. Because the genetics are identical, all it takes is one disease outbreak and the whole system fails. A classic modern example of this is the vulnerability of the Cavendish banana, which is currently threatened globally by a single fungus, precisely because it is grown in massive, identical monocultures without a shred of biological insurance. But then on the other hand, we have self-regulating polyculture. By mixing crops, trees, and livestock, you actively create that biological insurance. Different species support each other, they share deep soil nutrients, and they naturally deter pests. You are literally replacing expensive, destructive external inputs with locally adapted, living intelligence. And the financial and biological victory of this polyculture approach is just staggering when you actually look at the numbers. This is what it means to use and value diversity. Consider Mark Shepard's New Forest Farm in Wisconsin and compare it to conventional monoculture corn grown in the exact same region. The conventional system, heavily reliant on expensive fertilizers and fossil fuels, yields around $500 to $1,500 an acre. Shepard's farm, which is a fully integrated polyculture, yields $5,000 to $8,000 an acre. How does he pull that off? By grazing animals like cattle and pigs directly beneath productive canopy layers of hickory nuts, hazelnuts, and apples, right alongside perennial vegetables and mushrooms. It turns out, when you stack functions and utilize vertical space, your yield is pretty much limited only by your imagination. This exact same integrated thinking applies directly to how we handle our absolute most precious resource, water. Let's trace the journey of water. By applying the principle to catch and store energy, we can completely flip the script. In typical industrial systems, excess water is treated as a nuisance, something to be drained away as fast as possible. But in ecological design, every rainstorm is free, vital energy. Did you know that just 1 inch of rain on a 1,000-square-foot roof yields over 620 gallons of water? By using simple earthworks like swales, which are just shallow trenches built on contour across the landscape, we intentionally slow water down, spread it out, and sink it deep into the earth. We aren't just superficially watering plants here, we are recharging a massive soil battery. The earth literally holds that moisture in reserve so deep-rooted systems can pump it right back up to the surface during a severe drought. So what happens when we truly commit to producing zero waste? Well, in a healthy ecosystem, one organism's waste is absolutely another organism's lunch. Today, the food waste we send to landfills creates fugitive methane emissions, which is a massive greenhouse gas problem. But if that exact same waste is composted on-site and paired with cover crops, it transforms from a massive liability into a phenomenal fertility engine. To prove this, there was an incredibly exciting 19-year scientific trial conducted at UC Davis's Russell Ranch. The researchers wanted to study the life cycle of soil carbon in a closed loop to see exactly what happens to the microscopic life and carbon profile of a farm when we start treating organic waste as a critical, localized resource rather than just a disposal problem. And the results from that 19-year UC Davis trial were nothing short of spectacular. 12.6%. The plots treated with on-site compost and winter cover crops increased their total soil carbon by an astounding 12.6%. That is a massive gain on a molecular level, vastly exceeding standard international targets for agricultural carbon sequestration. Just think about what this means for global climate targets and the future of our atmosphere. If we applied this at scale across global agricultural lands, this isn't just harm reduction anymore, it's active planetary regeneration. It scientifically proves that by closing the loop and genuinely producing no waste, we can actively pull carbon from the air and store it safely back in the ground where it belongs. Okay, so how do we go about curing that feedback blindness we talked about earlier? We use the principle apply self-regulation and accept feedback. A fascinating study from 2021 showed that simply interplanting garlic with peppers fundamentally shifted the soil bacterial populations in favor of beneficial microbes. Now, why does this work? Well, the garlic roots release specific chemical exudates into the soil that actively deter pathogens, all while the strong scent of the garlic confuses airborne pests that are looking for the peppers. The result? A massive 60% reduction in pesticide use compared to the monoculture controls. By actually listening to the feedback of the biological system and simply tweaking the design to let plants cooperate, the ecosystem naturally begins to regulate and protect itself. Which brings us to the idea of integrating rather than segregating. Instead of isolating crops in rigid little rows, ecological design demands that we integrate them. When we connect diverse elements, they foster incredible mutualism. Think of the classic indigenous agricultural method known as the Three Sisters. The beans fix essential nitrogen into the soil to feed the heavy-feeding corn, while the strong corn stalk provides a natural trellis for the bean vines to climb. And then there's the critical third sister, squash. It grows low to the ground, with its large leaves acting as a living mulch that shades the soil, prevents weeds, and retains moisture. Studies actually show that this kind of highly integrated polyculture system achieves land equivalent ratios of 1.2 to 1.5, meaning You are getting 20 to 50% more total nutritional output from the exact same piece of land simply by putting the right things together. Now, you might be wondering, how does this scale beyond the farm? Our traditional globalized economic models are overwhelmingly linear in their design. They operate on a simple extractive track: extract, produce, consume, and discard. But permaculture design provides a deeply practical alternative: closed-loop circular economies. By emphasizing localism, closed-loop resource management, and cooperative economic models, we can take the exact same ecological patterns we see in a healthy forest or a regenerative farm and apply them to how we build our cities and conduct our trade. This fundamentally challenges that linear extractive paradigm, helping communities build genuine, long-term resilience against global supply chain shocks. And that naturally scales right into social permaculture. This is the idea that we aren't just designing physical landscapes, we are actively designing human relationships. By applying these ecological principles directly to our social structures, we move away from individualism and extraction and toward profound interconnectedness and reciprocity. We intentionally design systems that counter exploitation and place real value on incredibly diverse human perspectives and abilities. Think about really concrete examples like community tool libraries, where resources are shared locally rather than individually purchased and hoarded in a garage, or decentralized neighborhood energy grids that share solar power. These models build localized, bioregional economies that actually empower the people living in them. Earth care, people care, fair share. Holding this entire design framework together is a strict ethical bedrock. These three core ethics mean that every single design must run through a moral filter. This is honestly what separates permaculture from just being some clever agricultural trick for getting better yields. You could have a highly productive, hyper-efficient system, but if it ultimately destroys the local aquifer, well, it violates earth care. If it only benefits a wealthy few at the direct expense of the workers, it violates fair share. These ethics demand that we fundamentally set limits to our own consumption, that we enthusiastically redistribute our surpluses, and that we actively regenerate the living earth that we all share. It's pretty clear that the mechanical worldview has kind of run its course. But the ecological blueprint is sitting right in front of us, ready to be used. So I'll leave you with this to think about. Take a look at your life, your work, your community. Are you degenerating, or are you regenerating the systems around you? The choices we make in our daily designs ripple out far wider than we often realize. Thanks for hanging out with us for today's Explainer. Keep observing, keep interacting, and we'll see you next time.